Once again back to my YouTube channel. Today I am going to discuss another set of problem from KSET 2013 mathematics question paper. This is a part 3 video. Already I uploaded part 1, part 2. Just go to my YouTube channel, check the playlist. You may get part 1 videos as well as you may watch part 2 videos. Today this is part 3 of KSET 2013. First problem. If an of x which is equivalent to 1 plus x by n power n equal to 1 to which of the following statement is true? Option A, limit n tends to infinity an of x equal to 0 for all x. Option B, limit n tends to infinity an of x equal to 1 for all x. Option C, limit n tends to infinity an of x it is equivalent to e power x for all x. Option D, limit n tends to infinity an of x does not exist. In this problem, an of x is given as 1 plus x by n whole power n. We have to check out of the 4 options which one among the 4 options is the correct one. Solution. Limit n tends to infinity an of x. If limit n approaches infinity, this part x by n becomes 0, n becomes infinity. The problem will become 1 power infinity. Since it is of the form 1 power infinity, that is limit n tends to infinity 1 plus 0 power infinity. If you substitute limit n tends to infinity, this will become 0, n approaches towards infinity. That is of the form 1 power infinity. For problem which is of the form 1 power infinity, we may write like e power limit n tends to infinity f of x into g of x, x by n into n get cancelled. Answer is e power x. For this problem, option C is the correct one. Now I am going to discuss the second sum. If A is a 6 cross 6 matrix of rank 4, then its nullity is option A 10, option B 4, option C 2, option D 6. Here A is 6 cross 6, rank of A is 4, we have to find nullity. Solution: by rank nullity theorem, rank of A, nullity of A equal to dimension. Here dimension is 6, rank of A is 4, we have to find nullity of A. Nullity of A is 6 minus 4, which is equivalent to 2. Option C is the correct option. Third problem: if A and B are idempotent matrix, then AB is idempotent if option A, AB transpose equal to B transpose A transpose, option B, AB not equal to BA, option C, A square which is equal to B square, option D, AB equal to BA. Given A and B are idempotent. Solution: by definition of idempotent, A square equal to A and B square equal to prove AB idempotent, AB square must be equal to AB. What is AB square? AB into AB, A into BA into B, A BA, write it as AB into B, A square B square. Since A is idempotent, A square is A, B square which is equal to B, AB whole square equal to AB, which is possible only if AB which is equal to BA. For this problem, fourth option is the correct one, that is option D. Now I am going to discuss fourth problem. If y greater than 0, then integral 0 to infinity e power minus xy sin x by x dx. Option A, pi by 4 plus arc tan y. Option B, pi by 4 minus arc tan y. Option C, pi by 2 plus arc tan y. Pi by 2 minus arc tan y. It is given in this problem, we have to find the value for integral 0 to infinity e power minus xy sin x by x dx. I am going to use definition of Laplace transform for this problem to get the final answer. Solution. Definition of Laplace transform: L of f of t, which is equivalent to integral 0 to infinity e power minus st f of t dt. I am going to rewrite the problem: 0 to infinity e power minus xy e power minus st sin x by x sin t by t dx dt. This is exactly this one. This is nothing but L of f of t. Here what is L of f of t? L of sin t by t. This is nothing but integral s to infinity L of sin t into ds, which is integral s to infinity one by s square plus 1 into ds, because Laplace transform of sin t is 1 by s square plus 1. Therefore, integral s to infinity ds by s square plus 1. This is tan inverse of s limit s to infinity, which is equivalent to tan inverse of infinity minus tan inverse of s. This is pi by 2 minus tan inverse of s. Here it is in the form of arc tan. We may write tan inverse as pi by 2 minus arc tan s, which is equivalent to pi by 2 minus arc. In all the options it is in the form of arc tan y. I replace s by y. For this problem, answer is pi by 2 minus arc tan y. Option D is the correct option. Now I am going to discuss problem number 5. If S is the positively oriented circle, modulus of z minus 3i, which is equivalent to 2, what is the value of integral s dz by z square plus 4. Option A minus pi by 2. Option B pi by 2. Option C minus pi by 2 minus I pi by 2. Option D I pi by 2. Here the circle is modulus of z minus 3i, which is equivalent to 2. We have to find the value for the integral dz by z square plus 4. Solution. First of all, find the poles. For finding poles, equate denominator to 0. Z square plus 4 equivalent to 0. Z square minus 4. I square 4. Z equivalent to plus or minus I2. Now check among the two values for z, which one lies inside the circle mod z minus 3i, which is equivalent to 2. Z equal to 2i modulus of 2i minus 3i, which is equivalent to 2, that is which is less than 2. Z equal to minus 2i minus of 2i minus 3i, which is greater than 2. Z equal to minus 2i lies outside the circle. By Cauchy integral formula, integral C f of z dz by z minus a, which is equivalent to 2 pi f of a. We can write it as modulus of z minus 3i, which is equivalent to 2, one by z plus 2i dz by z minus 2i, which is equivalent to f of a. Here a is 2i, f of z is 1 by z plus 2i. Find f of 2i 1 by 4i, which is equivalent to 2 pi I f of 2i equivalent to 2 pi I 1 by 4i. I can cancel. Answer is pi by 2. Option B is the correct option for this problem. Now I am going to discuss sixth one. Let V be the space of all n cross n real skew symmetric matrices then dimension of V over R is n into n plus 1 by 2 n into n minus 1 by 2 n square minus 1 n square plus n. This is to find the dimension for all n cross n real skew symmetric matrix. Obviously, for symmetric matrix, dimension of V over R is n into n plus 1 by 2. For skew symmetric matrix, dimension is n into n minus 1 by 2. Option B is the correct. Now problem number 7th one. If 0 less than a less than b, then integral 0 to infinity tan inverse of ax minus tan inverse of bx by x into dx. Option A, pi by 2 log a by b pi by 6 log a by b pi by 4 log a by b. Option D, pi by 2 log b by a. We have to find the integral value. Out of the 4 options, one option may be the correct option. Solution. For this problem, I am going to apply DUIS. DUIS or Leibniz rule. DUIS means differentiation under integral sign. That is, d by dx of integral a of x to b of x f of x comma t dt, which is equivalent to integral a of x to b of x dou by dou x of x comma t into dt plus f of x comma upper limit b of x d by dx of b of x minus f of x comma a of x d by dx of lower limit a of x. This is DUIS or Leibniz rule. The problem is, take it as I integral 0 to infinity tan inverse of ax by x minus 0 to infinity tan inverse of bx by bx by x. This, take this one as I1, this one as I2. First find I1. What is I1? Integral 0 to infinity tan inverse of ax by x. Differentiate with respect to a. di1 with a, which is equivalent to, I am applying duis. With respect to a means integral 0 to infinity 1 by x, differentiation of tan inverse of ax 1 by 1 plus ax the whole square into x. I am differentiating with respect to a inside the integral into dx. Upper limit is infinity, therefore 0, lower limit is 0, therefore 0. Since I am getting only this value, x will get cancelled. Integral 0 to infinity dx by 1 plus ax the whole square. Put ax as some t, a into 1, which is equivalent to dt by dx, a dx equivalent to dt, dx equal to dt by a. Therefore, integral 0 to infinity dt by a 1 plus t square, which is equivalent to 1 by a integral 0 to infinity dt by 1 plus t square. This is 1 by a tan inverse of t with limit 0 to infinity, which is equivalent to 1 by a tan inverse of infinity tan inverse of 0, which is equivalent to 1 by a pi by 2 minus 0. This is di1 by dA. di1 equal to pi by 2 dA by a, integrate both sides, I1 equivalent to pi by 2 log a. Similarly, if you find for the second integral I2, the answer is pi by 2 log b. Therefore, I equal to pi by 2 log a minus pi by 2 log b, pi by 2 log a minus log b, log m minus log n, log m by n, pi by 2 log a by b. This is answer for I. For this problem, pi by 2 log a by b, option A is the correct option for the 7th sum. 8th sum, the general solution of dou square theta dou x square plus dou square theta dou y square, which is equivalent to 0, is of the form option A, theta equal to c into f of x plus iy plus g of iy, option B, theta equal to f of x plus y plus g of x minus y, option C, theta equal to x plus iy plus g of x minus iy, option D, theta equal to g of x plus iy plus f of ix. This is second order partial differential equation. It is given in the form of dou square theta by dou x square plus dou square theta by dou y square, which is homogeneous because of RHS 0. We have to find only complementary function for this homogeneous second order PDE. Solution: we can write dou square theta by dou x square as some d square, dou square theta by dou y square as d dash square of theta, which is equal to 0. Here I am using operator caps D for dou by dou x, caps D dash for dou by dou y. Replace D by M and D dash by 1. It becomes M square plus 1, which is equivalent to 0. This is auxiliary equation. M square is nothing but minus 1. This is nothing but I square. M equivalent to plus or minus I. Therefore, complementary function theta equal to either write in the form of f of x plus iy plus g of x minus iy, or theta, which is equivalent to f of y plus ix plus g of y minus ix. In this problem, it is given in the form of theta equal to f of x plus iy plus g of x minus iy. For this problem, option C is the correct one. Ninth one: if S and T are linear transformation on R2, defined by S of x comma y as y comma x and T of x comma y as 0 comma x, then first option s square equal to I, t square equal to 0, s square equal to s, t square equal to 0, s square equal to s, t square equal to I. Option D, s square equal to I, t square which is equal to I. Here s and t is given as linear transformation defined by s of x comma y equal to y comma x, and t is given as x comma y equal to 0 comma s. We have to check whether which one of the four option is the correct one. Solution. First of all, find s square of x comma y. This can be written as x composition of s, x comma y. S composition of s means s into s of x comma y, which is equal to, what is s of x comma y? S of y comma x. See, s of x comma y is y comma x. In the first position x we have y, in the second position y we have x. Therefore s of y comma x is first position. See, x comma y under s we are getting y comma x. For s of y comma x we will get x comma y. Therefore s square of x comma y is x comma y. This is only possible for identity transformation. Therefore s square which is equal to I. Now I am going to check for t square of x comma y. It can be written as t composition t of x comma y, t of x comma y. For t of x comma y it is given as 0 comma x. T of x comma is 0 comma x. Now I am going to find t of 0 comma x. T of 0 comma x which is equal to C under t 0 comma x, first value is 0. For image of t under x is 0. It is given in the problem itself. See, image of x comma y under t is 0 comma x. That is t of x comma y is 0 comma x. For t of 0 comma x, first position 0 is take it as 0. For x, image is 0. Therefore t square of x comma y is 0 comma 0, which is equal to 0. Therefore t square is 0, s square is I. First option is the correct option. I am going to discuss the last problem in this video, 10th one. Which one of the following transformation reduces the differential equation dz by dx plus z by x log z, which is equal to z by x square log z the whole square into the form du by dx px of u, which is equal to A, option A, u equal to log z, option B, u equal to 1 by log z, option C, u equal to e power z, option D, u equal to log z the whole square. In this problem, given in the form of two equation, one is given as dz by dx plus z by x log z equal to z by x square log z the whole square. We have to convert this problem into this form by using which one of the value of u we may get this equation du by dx plus px of u, which is equal to q of x. Transform this equation 1 into 2 by using which among the following option, whether u is log z or u is e power z or u is 1 by log z or u equal to log z the whole square. What is given? Solution. dz by dx plus z by log x log z equal to z by x square log z the whole square. First of all, divide by log z whole square. 1 by log z the whole square dz by dx plus z by x into log z, which is equal to z by x square. Now divide by z. 1 by z log z whole square dz by dx plus 1 by x into log z, which is equal to 1 by x square. Put u equal to 1 by log z. du by dx, it becomes minus 1 by log z the whole square into dz by dx. If we differentiate u with respect to x, 1 by log z becomes minus 1 by log z the whole square. Differentiation of log z is 1 by z. Differentiation of z with respect to x is dz by dx. Chain rule. Which implies minus du by dx which is equivalent to 1 by log z the whole square into 1 by z into dz by dx. For this 1 by z log z whole square dz by dx, this is nothing but minus du by dx. Therefore, this equation becomes minus du by dx plus 1 by x. 1 by log z is u, which is equivalent to 1 by x square. Multiply by minus on both sides, du by dx minus u by x, which is equivalent to minus 1 by x square. This is of the form du by dx plus p of x of u, which is equivalent to q of x. Therefore, we have convert dz by dx plus z by x log z, which is equivalent to z by x square log z whole square, in the form of du by dx minus u by x, which is equivalent to minus 1 by x square, which is nothing but du by dx plus p of x into u, which is equivalent to some q of x. This happen only by taking what is u? 1 by log z. For this problem, option B is the correct option. This is part 3 of video KSET 2013 Mathematical Science question paper. I already uploaded part 1 and part 2 in my YouTube channel. You just check it out in my playlist. It is available in KSET playlist. This is part 3 of Mathematical Science KSET 2013 Mathematical Science question paper. I will upload more problems from KSET 2013. Subscribe my channel, share my channel to your friend and like my channel. Thank you.